Okay, happy day and welcome. So today we are taking a look at the stoichiometry worksheet and working on conversions from mole to mole. Okay, so the first question that I have for everybody is, what is stoichiometry? So everybody, it is figuring out the amount of one substance when you know the amount of another. Perfect. Don't forget that. Okay, so you can go ahead and you can write that in for number one if you want to. So it says it's a fancy word for the mathematics of chemistry, and it's the process of really just calculating if you know how many grams you're starting with, how much of maybe a product or how much of another reactant you have. You can go forward or you can go backwards when you're doing stoichiometry. So it says we're going to use what are called equalities or conversion factors. Everybody say conversion factors. Conversion factors are what we use to convert something, okay? Sometimes they're called equalities, or I call them bridges, okay? Most people don't call them bridges. I call them bridges. So if you're on maybe a standardized test or something, or somebody says, didn't you learn conversion factors in chemistry? And you're like, yeah, I learned conversion. So conversion factors are basically just going to be equalities or even like ratios. It's important to note that coefficients, go ahead and circle the word coefficients in a balanced equation. We know they're the numbers in front of the substance. We know that they're not the numbers in the front of the substance. They're going to really tell us three things, but one thing major. The one major thing they tell us is moles. I want you to draw an arrow from coefficients to moles, okay? So when you see those coefficients in a balanced equation, those numbers in front, they're basically just telling you how many moles do you need to react in order to produce a certain number of moles, okay? And remember, all the mole is it's a number. Just like the dozen we said is equal to how many? 12. The mole, anybody remember what number it is? 6.02 times 10 to the 23rd. Very nice. And so this number is really, really, really big. And so if you have a lot of something, you want to use moles in order to show that. Okay. So and we'll get into that a little bit more later. I'll show you what a mole actually looks like. Coefficients also tell us liters. So draw an arrow to liters and an arrow right down here to molecules. Okay. So they tell us moles, liters, and molecules, but we're going to focus on moles. Okay. So our focus is just going to be on moles. It's important to remember that there's a difference between what the coefficients are telling you versus what is conserved. So I want to make sure that I go over what is actually conserved. Well, when we talk about conservation, there are really like three conservation laws. One is conservation of matter. A second one is called conservation of, tell me another one. I heard it. Mass. And there's a third one, conservation of energy. Perfect. Those are the three. So when we say matter, we're actually talking about atoms. Go ahead and underline atoms. So our number of atoms are the same between the reactants and the products. Not only the number, but the actual type of atom. So if I have 3 hydrogens on the left, how many hydrogens do we have to have on the right? 3. And remember when we were doing those like the beads and the balanced equations, you have to have that same number on both sides. The second thing is mass. And what we say about mass is, if you add up all of your reactants' mass, you weigh them all, and you weigh all the products' mass, they have to be exactly the same. So mass is never lost. Sometimes what happens, though, is it turns into a gas, and people think, oh, well, I weighed it, and it doesn't weigh as much as it did. If you could trap the gas maybe in a balloon and weigh it, it would actually equal out, okay? So it is the same. And the third one is energy, and so we know that energy is always conserved as well, so it's either lost or gained, but it's not just going to disappear, okay? So it's going to show up somewhere else. So those are kind of the three. Okay, so let's come down here and let's fill this in. So we said coefficients tell us three things. What three things did we draw arrows to from coefficients? Coefficients, not coefficients. Moles, liters, and molecules. Okay, on your quiz, there will be a question that will ask you either what do the coefficients tell you and or what's conserved. What's conserved is a little bit different. So what's conserved means what stays the same, not what are the numbers in front telling us. So what actually stays the same or is conserved in a chemical reaction? Atoms. Yep. Atoms, which is matter. And then we said mass. And so sometimes what you'll see grams or kilograms or something like that. And the last one we said was energy. Perfect. Okay, so whether it's like exothermic or endothermic, and we know that there are laws of conservation of each one of these, of matter, of mass, and of energy. There are laws around those. Okay. So one of the important parts of, I want to say even the reason why we're even doing stoichiometry, a big part of it is so that you can understand ratios, okay, so that you get some practice with dealing with ratios. And the way that ratios work, I always like to use a car example, and I'll say something like, okay, how many tires are on your average car, your normal car, regular like just sedan or whatever? 4. We know that there are 4, okay? So if I had, instead of having just one car, and then I'm just going to kind of show like as if there were like, there was another tire back there. What if instead I had 4 cars, okay? Well, if I had 4 cars, how many tires would I have? And you guys know what to do. You would do what? You would multiply 4 times 4. So if I have 1 car, then I know I'm going to have 4 tires. So if I have 4 cars, I know I'm going to have 16 tires, okay? And so what if I had 20 cars? What am I essentially doing? You're multiplying by that number. So now how many tires would I have? I would have 80, okay? So I would have 80. And so what you basically do, and the way that this can actually be written, is I can write it, instead of writing it this way, I can actually say 1 car is 4 tires, and I can flip it, okay? I can say, try to make a little bit more room on this. Let's see if I can. Let's see if I can just move it. Oh. It's not letting me move it. That's okay. Okay, so then if I have 4 cars, then I know that I can do, to my pen, if I have 4 cars, we said that that would be 16 tires. And if I had 20, I'm going to do it on this side, 20 cars, then that would be 80 tires. I want you to tell me something mathematically about this number here and this number here versus this fraction right here. What can you tell me? If you reduce this down, what do you get? 1/4. And if you reduce this down, what do you get? 1/4. Ratios, all they are is it's everything multiplied by 2, or everything multiplied by 3, or everything multiplied by 10, okay? So when you do to one, you're going to do to the other, and that's the way that algebra works anyway, okay? So when you're going to look at these coefficients, it's basically just going to give us a ratio. The only thing is, sometimes the numbers aren't that easy to use. They're not that, they're not going to be even numbers, maybe they're decimal numbers, and so sometimes it can get a little bit confusing, okay? So how do you deal with this when you have a calculation and I give you some random number and I say, well, what if you had 67, right? If you had 67 cars, then what are you supposed to do, right? So now it's a little bit more challenging. So what we're going to do is we're going to use these bridges to try to help us with these calculations, all right? And it's going to go really fast, all right? Okay, so first question is, well, first thing I want to do is I want to make sure that we circle our coefficients. What coefficients do you see in here in this equation? I see a 3, very good, and I heard you see a 2. What's this one? A 1. If there's no number there, I want you to write the 1 in, and I want you to circle it. Okay, so I do want you to actually write the 1 in. All right, so when I ask you for a ratio, it goes in the order as it's written. So in this case, because I might ask you for NH3 to N2, that's different. I want N2 to NH3. On the count of 3, take a look. What you're going to do is you're going to find the N2, find the number that's attached, find the NH3, find the number that's attached, and tell me what numbers you see. 1, 2, 3, go. And then you say, for this, you say 2. You use TO. Okay, so what are we going to say? Ready? 1, 2, 3, go. I want N2 to NH3. Ready? Everybody. Everybody ready? 1, 2, 3, go. 1 to 2. Very good. So that you would say is a 1 to 2 ratio. Okay. Now when you're going to do your bridge, it might look a little bit different. Let's try B. What's the ratio of moles of NH3 to H2? Okay, on the count of 3, I want NH3 to H2. Okay, ready? 1, 2, 3, go. I'm hearing two different things. So you're finding NH3 and you're finding H2. Ready? 1, 2, 3, go. 2 to 3. It's a 2 to 3. Okay. Nope. You have to find the one, whichever one is here. That's the one that you're going to use. Okay. Let's try letter C. Okay. On the count of 3 again. 1, 2, 3, go. 3 to 2. Awesome. Okay. Go ahead and fill in the rest of them on here. It should be pretty fast. We're not going to do those together. I think you got the idea. Okay. Let me just make sure here. Okay, so now we're on number 4. There is a 4-step process that I always like to use that I have actually come up with. So it's a silly way to remember how to solve problems, but I'm going to tell you it's going to help you so much. What my hope is that you're going to get to a point. By the way, nobody work ahead on this. So if you've answered number 5, please do not answer number 6 or 7. Okay, so please do not work ahead on this. So for number 4, it goes blank what you want, blank what you got, throw in a blank, and cross a blah, 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 blah. Okay, so let's see if you guys remember what it is. Circle what you want. Very good. So circle what you want. Write what you got. Good. Throw in a bridge, and we're going to talk about this bridge in just a second. And cross your units opposite. And so we're going to go over this in just a second, but let's say it together one more time. So it's going to be circle what you want, write what you got, throw in a bridge, and cross your units opposite. Okay, ready? Here we go. Say it with me. Circle what you want, write what you got, throw in a bridge, and cross your units opposite. Okay. So let's try question 5 together. And so what I've done in the past is I've timed myself just to check to see, like, how long does it take me to actually teach it? But then we're going to see what happens in number 6. So nobody do 6 or 7. Okay, so we are going to do number 5 together. I do want to time it, so I'm going to start my time right now. So I'm going to ask questions. So the first thing we know to do is circle what you want. Okay, so on the count of 3, what are we looking for? Look for the question. 1, 2, 3, go. Okay, yes. Okay, but it is moles of NH3. So it's moles of NH3. You do want the whole thing. Okay, you want moles of NH3. Write what you've got on the count of 3. What number are they telling us? 1, 2, 3. 2.50. Now we want to keep going because you don't just want to say 2.5. It's like saying 2.5 marshmallows or 2.5 graham crackers. What do you have 2.5 of, right? So it's moles. We're going to abbreviate MOL. And then it's N2. Make sure you write what it is. This is very important, okay? Do not get lazy on this part. Circle what you want. Write what you got. What do we do next? Throw in a bridge. Throw in a bridge. Now, a bridge can either look like this. I'm not going to do it this way. It's a numerator and a denominator. The way that I'm going to do it is it's going to look like a data table, kind of. So it's going to look like I'm entering a table. And so circle what you want. Write what you got. Throw in a bridge and cross your units opposite. Just this, okay? Don't draw the arrow, but when I say opposite, I really mean diagonal, okay? So you don't have to draw the arrow, but it's just going to be mole of N2, and very important that you write N2 down there. So people will get confused and they'll go, oh, shoot, I did my ratio opposite. Or they'll say, Ms. Ismail, it can be one of 2 answers. Which one is it? Is it 2 over 3 or 3 over 2? And I'll say, well, if you did this correctly, then you don't have to guess. It's not a guessing game, okay? What are we trying to get to? We're trying to get to moles of NH3. So the one that you're trying to get to is going to go on top. Okay, that's the one that we're looking for. And these bridges, by the way, can be 4 or 5 bridges long. Just happens to be that these mole-to-mole ratios, which we will do ones that are a little bit longer, but these mole-to-mole ratios are just going to be one-step problems. Okay, so now what we're going to do is we're going to take a look at our ratios. We need to know our ratios. So look it up at your balanced equation, and on the count of 3, I want to know what my ratio is. Find NH3 and find N2. And then you're going to say something over something. So 6 over 4, 3 over 5, whatever your numbers are. Okay, ready? 1, 2, 3, go. Very good. The correct answer is, hold on, 2 over 1, because if we look, there's the 2 from the NH3, there's the 1 from the N2, and you literally just fill the numbers in. Now, you're not going to need to do this just right now for this problem. If we go to calculate this, switch to red. If we go to put this in our calculator, what do? We would do 2.50 times 2 divided by 1. Everybody say denominator divide. Denominator divide. If it's in the denominator, we're going to divide, but we're dividing by 1, so we're just going to leave it, because anything divided by itself, or by 1 is itself. So then our answer is 5. I like doing 3 digits. You're going to see on the back of the page, I'm going to ask you to do 3 digits. Okay, what happens? You know how x over x equals 1, or 20 over 20 equals 1? Anything over itself equals 1. Moles of N2 divided by moles of N2 cancels out. It's equal to 1. So all I'm left with here is mole of NH3, and this is our final answer. Okay, so what I'm going to do now, okay, that took a little bit longer. That took about 3, I didn't stop it, I didn't pause it, but it took about 3.5 minutes or so. My test for you is, can you do number 6 in under 1 minute? Okay, so I'm going to stop my time here, and let's see how we do. So I know I was timing you, and I know that it rushes things. So let's go over this problem. The correct answer is 9.15. If you didn't get 9.15, there were a couple of mistakes that I saw that I had noticed that people did. Do not do number 7. Okay, no, number 7 is not going to be for fruit snacks anyway, so don't do number 7 because I want everybody to be able to do it in under a minute, okay, correctly. So it says, so 6.1 moles, blah, blah, blah. Circle what you want. We know what we're looking for is moles of H2. Write what you've got, 6.10 moles of NH3. If you don't write this down, you are going to possibly just be guessing, okay? We don't want you to be guessing. Throw in a bridge and cross your units opposite, which means I'm going to cross all of this down here. Okay, let me take questions right now. Any questions on this part? Are you okay up to here? Are we okay? Yes? Thumbs up? We're okay up to here? So most of you got to this point. So now the question is, where do you go after that, right? Well, what are you looking for? It says moles of H2. So you want to see, what did you circle? That's going to go on top. What you circled goes on top, okay? So now I'm going to look at my ratio. And on the count of 3, what is the correct ratio if you have H2 over NH3? I'm going to find my H2. And I want to find my NH3. On the count of 3, what's the correct ratio? Something over something. 3, 2, 1, go. 3 over 2. Awesome. So it's 3 over 2. Okay, now, if you got this part, and then these are going to cancel out because they're the same. If you got this part, the only other thing you have to do is know how to plug it into your calculator, right? So what do we do if they're both in the numerator? Multiply. I think some people may have added instead of multiplying. And then what do you do if it's in the denominator? Divide. Do not divide before you multiply. So the correct order of operations is to multiply and then divide. Okay? So we've got 6.1 times 3 divided by 2. I'm saying in your calculator. Okay? So 6.1 times 3 divided by 2. And the correct answer we said was 9.15. And now it's moles of H2. And let's box that in. Okay, so let's do this again. Let's try to get this in under 1 minute. Circle what you want, write what you got, throw in a bridge, cross units opposite, and let's see how many of you can get this one right. Your time starts now. Hey, this is amazing. So it looked like about 75% of you were under a minute and a half. We're at 2 minutes now. So if you just got it now, that's really good. If you're under 2 minutes on any one of these problems, that's awesome. Okay, so fastest thing. The fastest thing is actually to do it correctly from the beginning. Don't shortcut, okay? So circle what you want, write what you've got, 5.40 moles of the H2, throw in a bridge, and cross your units opposite. It takes a second. It really doesn't take that long. I'm going to cross off my moles of H2 because those are going to cancel out in just a second. Okay, so I'm not going to do it yet, but I do know that's why I do that. That's why you have that there. Okay, so I know I'm going to moles of NH3 because that's what I'm looking for. That's what I circled. So what you circled should be at the end there. And now I'm going to use my ratio. On the count of 3, everybody, your ratio of NH3 to H2 is what? 1, 2, 3. 2 over 3. Yes, thank you. Sorry, I forgot to count. Okay, so it's 2 over 3. So all you're going to do in your calculator is 5.40 times 2 divided by 3, which gives you 3.6. So 3.6, because I like 3 digits, I'm going to add a 0 there, but you don't have to, okay? It's still the correct answer. And so again, that's moles of NH3. Okay, so what are we doing right now? And then again, our moles of H2 cancel out there. What we're going to do now is you're going to flip over to the back. There are 7 problems on the back, okay? I want you to see how long, I'm going to give you about 20 minutes to do this. How long could somebody potentially take, though? 6 or 7 minutes. If you're doing these at 40, some of you were at 40 seconds. If you're doing these at 40 seconds a piece, you're going to be done really quickly, okay? But I do need you to do the bridge. I need you to show the bridge. I need you to make sure that you're calculating it. On the bottom of the page, the correct answers are there. I do not want you looking at the correct answers until you finish the problem. So please make sure you finish the problem. And happy day to all of you.